Okay, today we're going to look at trig substitution, specifically a little bit harder one. But before we do that, I want to make sure we have the fundamentals in place. So we use trig subs as sort of a last resort when we can't figure out a better way to solve an integral, let's say with u substitution or integration by parts. And it usually happens when we have a radical in the denominator and there's no easy way to get rid of it, like in this case. So the idea is to convert this form. This is called, I call the x my u squared, and the 3 right there is my a squared. The idea is to convert this u squared plus a squared into some sort of trig function using the Pythagorean theorem. And you'll see how that works in a second. So our first step right here is we want to make sure that we can factor this so that we have no constants in here except 1. We don't like this 3 in here. We want this to be a 1. Now, there's no real good way to get this to be a 1 except to fake it. And that's what I'm going to do. But before we do that, we have to figure out how do we get a trig identity that works here. Our first step is to always start with Old Faithful. Sine squared theta plus cosine squared theta equals 1. Now again, the idea is we're going to take the square root of both sides right here, and that's going to absolve our radical. Now, this is sort of in the form u squared plus u squared equals a, and that's no good. So we got to improvise. If I divide by cosine on both sides, cosine squared theta, and this of course becomes 1, I'm going to get tan squared theta plus 1 equals 1 over cosine is secant squared theta. Now that's in my form u squared, which is again one of my trig functions, plus a squared, a constant, equals, I don't know, some value. And so notice, this is secant squared. So if I can substitute in tan squared plus 1, I can put in a secant squared in this, take the square root of that, and then boom, away goes my radical. And so that's our strategy. We're not quite there yet though. So I know I got to use tan squared theta plus 1, but how am I going to implement this? Well, like I said before, we have to somehow fake getting this to be a 1. And one way to do that is to add a 3 in right here and then factor it out. So that's what I'm going to do, and watch closely. I'm going to say my x equals, now this is just x, I'm going to say my x equals the square root of 3 tan theta. Now, when I square this, I get x squared equals 3 tan squared theta. Now, if I have 3 tan squared theta plus 3, I can factor that 3 out, and I get tan squared plus 1. Boom, tan squared plus 1 equals secant squared. I get rid of my radical. So that's where we're headed. Now, I set up my trig function, my trig equation right here. My next step is when I have my tan theta, I got to make a triangle because I got to see what I'm working with. And this sometimes can trip people up, but we'll see what's going on here. So I have my theta right here, and always draw the picture. I have my theta right here, and I know that I'm going to solve for this, so tan theta is going to equal x over root 3. I know that this is my adjacent side, this is my opposite side, this is my adjacent side, so this is x over root 3, so this is going to be the square root of x squared plus 3. Okay, I feel very good about this because what's inside this radical, x squared plus root 3, is the same thing as what's inside this radical right here. So I'm on the right track. Okay, so I'm going to go ahead and substitute in for my x. Of course, we got to substitute in for the dx too, so let's go ahead and do that. So we'll take a derivative of this guy right here. So pulling that down, we'll say, we'll ddx both sides. We'll say dx equals root 3 secant squared theta d theta. And these trig derivatives and integrals, there's something you got to memorize. I know it's a pain in the butt, but tough. It's what you do when you're doing calculus. This is the easy part, is memorizing. Okay, so we have our dx and we have our x. Now we just got to substitute, and really the integral solves itself. Famous last words. So we have the integral, oh boy, we have the integral of -3 root 3 tan theta dx. Dx is root 3 secant squared theta, is all d theta, divided by, okay, here we have x squared plus 3 to the 3/2 power. Well, x squared, that's going to be 3 tan squared theta. So I have 3 tan squared theta plus 3. And this is raised to the 3/2 power. This looks like an absolute mess, but I promise you it simplifies out beautifully because we were careful at the beginning. So you'll notice I have a 3 in both of these right here, and just like I promised before, we fudged this so that we created a 3 right here, and we can factor that out to get tan squared plus 1. Okay, so it ends up factoring out something like this. First I'm going to go ahead and combine these two. This is root 3 times root 3, that's 3 times -3, we get -9. And then on the top we get tan theta times secant squared theta. So we have tan theta secant squared theta d theta, already looking better. And then on the bottom we have a 3 to the 3/2 power, remember I'm factoring that out, times tan squared theta plus 1 to the 3/2. Ooh, wait, I have tan squared theta plus 1 equals secant squared theta. Again, we're trying to fudge out this 3 so we can get our trig identity, take the square root, and boom, get this. So I'm going to substitute this in right here, and I'm going to simplify this a little bit right here as well. So what we get is tan theta, excuse me, secant squared theta, d theta, and here we have -9 over 3 root 3. This becomes secant squared theta to the 3/2. Now, let's go ahead and write that out here so we don't make any mistakes. We have secant theta squared to the 3/2. So this 2 and this 2 cancel, so I get secant cubed theta. When in doubt, always write out your steps. In fact, just always write your steps, period. So we're going to get secant cubed theta. What do you know? Boom. These cancel. I get tangent over secant. I can go ahead and cancel these guys out too. I get -3 over root 3 on the top. Okay. So let's keep going with this. -3 over root 3. I get tan theta over secant theta. So I'm going to write that as sine over cosine. And then divided by secant, that's the same thing as multiplying by cosine. Cosine theta over 1, d theta. Those end up canceling. So I'm going to be integrating my sine theta. That's, of course, negative cosine theta. So let's move over here. we're going to get negative 3 over root 3. Oh, wait, that's a positive. Cosine theta plus c. Okay, so we're almost done. Got one thing left though. If you remember your changing limits of integrals, when you do a u sub, this is the same idea. We start with x's, we end with thetas. We don't like that. We want to start with x's, end with x's. So going back to my triangle, I know that my cosine of theta is just my adjacent over my hypotenuse. So that's going to be 3 over root 3 times adjacent over hypotenuse. What do you know? These cancel. Over the square roots of x squared plus 3 plus c. Cancel, cancel. Our final answer then is going to be 3 over the square root of x squared plus 3 plus c. Boom. We just finished our trig sub. And so that is how we do trig substitution. In this case, we use tangent. So let's review over our steps again. The first thing we had to do was recognize that this was going to be a trig sub because it's a radical in our denominator, and there's no good way to solve this using u subs or integration by parts. The second thing we had to do was recognize that the proper form of this is u squared plus a squared, a variable plus a constant. So we had to put the variable in terms of the trig function and then put the constants in front of that by dividing. So we ended up getting tangent squared theta plus 1 equals secant squared theta. We always start from our normal trig identity, sine squared plus cos squared equals 1. After that, we had to create some sort of fudge factor so we could factor out the 3. We did that by saying x was equal to root 3 tan theta, so that when we squared it, we got a 3 that we could factor out of both of these terms. After we decided our x was equal to root 3 tan theta, then we created a triangle based on that. We said this was the opposite side, this was the adjacent side, and then using the Pythagorean theorem, we got the hypotenuse. After that, we took the derivative of this to find the dx, and then we plugged that whole puppy into here. And this became a huge mess. We simplified very carefully, noting that after we factored out the 3, the tan squared theta plus 1 just becomes a secant squared. And that's how we got rid of our radical. And so simplifying, once we integrated, we had to finish by converting our theta in terms of x. And so that's what we did, going back to our triangle right here. Thanks for watching, and I hope this helped you out with your Calculus 2.